So looking at this topology, I kind of messed up. I did this whole hour thing where I went ahead and I configured all of these switches, the VPCs, the SVIs, and all that stuff, just to find out that the audio had double recorded. It was a huge echo, and there's no way I can do that. So what I'm going to do is I'm going to briefly go over what I did, and then I'm going to show you on the secondary campus, because the process is the same. That way we can kind of get to work and get this network up and running. So I'm going to first thing we're going to do is we're going to take a look at the distribution switch for the main campus. And it's probably been a while. I have to reconnect to it, so give me a second. Okay. Okay. So I'm going to go over the running config. That way we can go over what was configured on the distribution switch and why. And I'm going to try to do this quickly so then I can show you how to actually do it. So doing a show run, we're going to look at the configuration. And it's building. Okay. So besides the basic stuff, we have a user, a local user created, a password, and all that good stuff. What we did, let me actually get it all to print out, and then I'll go one by one. The first thing we had to do was, because we're using this this switch here as a distribution switch, this switch was going to handle all of the InterVlan routing between the three buildings. So your VLANs, which is layer 2 only, is going to sit on the switch, and that's it. Just the VLANs, and just the VLANs for the department. So it's VLAN 20, 30, 40, 50, 60, 70, 80, and 90. Each department has its own separate VLAN and its own separate IP network. So the first thing we had to do was go into each switch, and I'll just use the admin switch for an example. Actually, didn't have a Cisco account. Okay. So we went into each switch, and first thing we did was configure the VLANs. So we created the admin VLAN. Then we had to take the interface that the host device was connected to and assign it to that VLAN. So G01 here on the switch is connected to the host device on VLAN 20. So we assigned it here to VLAN 20, which we have named admin. Then we had to create a trunk link. A trunk link allows tagged packets to traverse between switches. Without it, there would be no way for this PC to talk to any PC on another switch, or to cross switches to even talk to the same device on the same VLAN. If you send a tagged packet, or a packet with a VLAN ID on it that's tagged, they're called tags. There's a 12-bit numerical value that gets inserted into the header of the Mac, the Mac header. It contains a VLAN ID. When the other switch gets it, it has no idea what to do with it. It's, I don't know what I'm doing with this. This is what? And it drops it. So when we create a trunk link allows those packets to pass transparently from one switch to another. So one side of the trunk link is here. So we created the trunk link here. We're using a 802.1q encapsulation. which I've explicitly told the switch to use that. I've also explicitly told the switch for this port, the G00, to be a trunk link. Now, if DTP is on, both sides would negotiate. I don't like DTP is dynamic trunking protocol. It allows both sides to negotiate the encapsulation method and the trunking and whether or not something is an access or a trunk port. Access ports, or access switch ports, or however you want to call them, are for exactly what they say. They are for access devices. So they were for printers and computers and all that stuff. That's only going to be an access port or an access device. A trunk port is what allows the layer 2 VLAN tags to traverse between switches. So we created, so again, just a quick recap, we created the VLAN, we assigned the access port to VLAN 20, and then we created the trunk port so that the tagged VLAN can traverse the network, as you can see here. And that's it. That's all we have to do on the switch. So then we do this on across each switches for their respective devices. So VLAN 30 was created here, right? This is access port for VLAN 30. This is a trunk port that this was the trunk port that hits the distribution switch, and it's the same across all of the switches. Now that allows devices in the same VLAN to talk to each other. So this admin PC here can talk to this admin PC here because they are on the same VLAN. But anytime you want to talk to another device on a different VLAN, you are going to need to do what's called InterVlan routing. And the way you do that is by creating an SVI, a sub-virtual interface. So the sub-virtual interfaces are created on the distribution switch because we are segregating out how traffic flows across the network by devices. So your access layer here, which is just your is only responsible for data that travels to access devices. Your distribution layer, which is where this distribution sits, distribution switch here, or it's L3 switch, which we're using as a distribution layer, will handle the communication internally between VLANs and between buildings. So that's why we create the sub-virtual interfaces on this switch and not on the others. Because these switches are not going to make forwarding or routing decisions or anything. We are going to leave that to the distribution layer. So we take a look at the distribution switch, and the process in the very beginning is kind of the same. We created all of the VLANs that are going to be across the network on the main campus. So we have VLAN 20, 30, 40, and so on for each corresponding VLANs across the 3 buildings here. So building A, B, and C, all of the VLANs have been created. Now, just like the other switches, then went ahead and made the other side of the links connecting to the access switches into trunk links. So all of these are trunk links. So if we go back and look, there are the trunk links. And I've explicitly told them to use 802.1q. I've explicitly made them trunk links. If they weren't, if they were using DTP, then instead of mode saying on, the mode would be auto. And I don't like the system telling me what it's going to do. I like to tell the system what to do. Once we created the trunk links and I created the VLANs, remember VLANs are layer 2. Then I had to create the layer 3 component, and that's where you make the SVIs, the sub-virtual interfaces. So if we do a show IP int brief, Here are the actual layer 3 interfaces. And each VLAN is its own separate IP network. Okay, the IP scheme I used worked for me. You may not do it the same way. That's fine. And I probably, if I did this over, I would probably change it. But these are all /24 networks, allowing up to 254, not 256, because you have the network address and the broadcast address, leaving you 254 hosts. So if you wanted to expand this out, you could. The VM I have is not the strongest in the world, so I have one device per VLAN. You can have up to 256 per subnet on these VLANs if you wanted to, if you so choose. But each, so they have the layer 2 VLANs up top, and then we created the virtual interfaces, assigned them IP addresses. Now the IP address we assign them as acts as a default gateway for the VLANs themselves. So when I take a device on VLAN 10, its default gateway is going to be the IP address that corresponds to the VLAN on the distribution switch. So, for example, VLAN 20, which is the admin VLAN, I've assigned 192.168.1.1. If I now go to the PC and I show you its IP information, it is on the VLAN 20 subnet with an IP address of 192.168.1.10. Its default gateway is the same IP address, is the IP address of the SVI on this switch. The reason being is once you do that, the distribution switch as an L3 will then make routing decisions between VLANs based on its routing table. So if I go ahead and I look at the routing table, all of the network addresses for each individual VLAN are on this switch. So what it means is that when on VLAN 20 I wanted to communicate with a device on VLAN 80, the packet will come in, will come out through the trunk link into the distribution switch. It will then look at its routing table and it goes, ah, I have a route for this. I know where to send this. And then it will forward the packet down the lane that it needs to go. That's what SVIs do. They allow for inter-VLAN communication between devices. Now that I've gone through that whole spiel of what I did, let me show you how to do it on this side. So I'm going to go ahead and to save memory on my VM, I'm actually going to shut off the main campus, and I'm going to bring up the secondary campus. And I actually don't need the server yet. We're not there yet. And then we're going to start them. Now going back to, again, I've said this multiple times. I don't know if I'm going to put in the video where I did it, but I've actually planned out VLAN and networks, and the networks for each VLAN and where they are. I won't do it from my head. I won't do it from memory. There was in the previous video that I made with double audio, there was some troubleshooting I had to do because I had missed a couple steps here and there. And writing things down, writing my design and writing the plan down made it very easy to go back and check and go, ah, this is the problem. Oh, I forgot to do this. So let's go ahead and I'm going to start with the easy one first. I'm going to configure the switch instead of the core switch. Now let me close these out because these are no longer on. Plus, these devices have to load up anyway. Okay. Now I have a base config that I like to use. I'm going to go ahead and just dump that on the switch. This is nothing for VLANs or anything like that. This is just basic local username, password, enabling SSH connections, things like that. So I'm going to go ahead and do that really quick. And I do this on all my switches. And I'll actually make this bigger. There we go. And because I'm running a VM, sometimes the buffer takes a while, and you typically won't see the switch look just like that. So I added the host name. I'm going to save the config. Actually, let me adjust this a little bit so I can see what I'm doing. Okay. So now we have the host name of IT department. So the IT department is going to be, let's see what floor we're on. So if we go back to topology, the IT department is on floor 1. So floor 1 I have set as VLAN 100. So we are going to go ahead and create the VLAN. So this is going to be VLAN 100. Now I don't have a name for it or department. I mean, there is in the brief. So let's take a quick look in the brief. So let's see. Staff and student labs are separated on separate floors. Faculty of Health and Sciences. So I can do this one of two ways. I can reuse the staff VLAN, or I can create a new one. Same thing for student. I'm actually going to create a new one. I'm just going to make them brand new. So VLAN 100 name. Let's put this as student lab. That's done. VLAN's there. So now, and I keep hitting end. I should hit exit. I hit end as a force of habit. I always have to go back into the terminal, config terminal. I don't know why. Or enable config mode. I don't know why I do that. I just do it. I actually want to see what this is connected to, because I know I have CDP running. So this is going to be the distribution switch. I haven't configured a host name yet, which is why it just says switch. But I know this is the distribution switch, and it's going to be on gig 00. So I know that's going to be my trunk link. Okay. So there are two PCs. The web server, I'm going to put on a separate VLAN. I'm not going to worry about that config right now. Right now, I'm just worried about VLAN 100, which is going to be this VPC right here, which is connected to interface G01. So I'm going to go ahead and assign G01 to VLAN 100. So int G01. I'm going to make this interface an access port, since this is an access device. So switch port mode access. And now I'm going to assign this switch port to VLAN 100. And I'm going to save the configuration. As a habit, every couple configs I do, I save it. Just so in case something happens, I have to shut down my lab or something, I don't have to go back in and I don't have to try to remember what I have to redo. Okay, so done. It's always good to verify. You should verify before saving the config. So yes, verify before you save. So now, if we show VLAN, we see we have VLAN 100, student lab, name student lab, with the access port assigned to it. We're done with the VLAN. Now what we're going to do is we are going to go and we're going to configure the trunk link between the switch and the distribution switch. So since I know I have CDP enabled, which a lot of times is not enabled by default, it can be a security risk, but in my lab, segregated from everything, it's enabled. So now I know. So now I'm going to go into interface G00. Now I want you to see this. If I try to do, it won't let me. It won't let me because DTP is enabled on these ports. So it's set to auto mode. I'm going to be an access or a trunk port depending on what comes through. I'm going to make a determination. I'm also going to determine what encapsulation mode I'm going to use. Don't like that. I tell the system what to do, not the other way around. And also, yeah, no, I just like telling the system what to do. So, their way around this, and I have to remember if this is the exact way of doing it, but I can set the encapsulation mode by doing switch port trunk encapsulation .1q. Once I set the encapsulation mode, then I can explicitly set it as a trunk port. And I can verify that by doing a show interface trunk. And there we go. It's using .1q. It's explicitly set as a trunk. G00. Allowed VLANs 1 and 100. Default management VLAN. It's the best practice. You really should disable that. Use a different VLAN, but we're not going to go into all of that right now. But this switch is now configured. I'm going to go ahead and jump a little bit and configure the VPC, only because I want to be able to test it once I do the distribution switch. And since I've pre-planned my IP networks, I already know what I'm going to give it. So I'm going to give it a 192.168. And did we say we're on floor 1? I think we did. This is floor 1. Right, so floor 1, I'm using a .31.10. The net mask, this is a CIDR 24/24, so 255.255.0. And the default gateway is going to be the IP address of the SVI for this VLAN. I've yet to create it. I'm going to. So it's 192.168.31.1. I always use a .1 for whatever I'm going to use as a gateway. It's just I've seen it done everywhere. A lot of engineers do it. And let's double check. Okay, so we have our IP address assigned, .10 and a /24. Our gateway is 31.1. So the VPC is good to go. I'm going to go ahead now and I'm going to configure the second switch here from floor 2. So let's open that up. And now that it's loaded up, I'm going to put on the base config that I did on the other one, which I have saved. And I have it saved here, right? I'll go over it briefly. So there's a enable password, local account, same thing. It's a secret password, right? And then if you want to go into console, you're going to use the local user database. You're going to do the same thing for the SSH connections. And then I have it set for hostname, so I can just type in a hostname once it comes up. So it's going to do all I could start messing with things with STP and things like that, which I have. I do have another one which has, the STP settings and everything done. But that's a little bit much for what I'm doing here. Now, if I'm not mistaken, I believe this is going to be student lab. And it is. Okay, and let's see. Okay, let's save that. Oh, now that I'm done with, I think I did save it up there. I did, and the rest was validation. Okay. The only reason why I don't validate the base config is because I've done it so many times. I know it's accurate. I know it works that I don't verify this. So, okay. So now that this is done, we're going to do the same process again. We're going to create the VLAN. So from the configuration menu, we're going to create VLAN 110. We're also going to give it the name student lab. And let's double check the topology to see what's connected. So we see here that it's going to be 0, 1 is connected to this the student lab. Okay, there's only one PC here. I can have up to 254. If I want to have a big lab, I only have one for VM constraints. So, but we know we're on interface G01. So I'm going to go int G01. I'm going to make it that it's a access switch port, so switch port mode access. And then I'm going to assign it to VLAN 110. And that's it. We're done. We have the VLAN up. We have the port assigned to the VLAN. So now whatever connects to that port, if we're not doing port security and things like that, which we're not in this video, whatever connects to the port is now assigned to VLAN 110. That's it. We're done with that. Now it is connected to the distribution switch, so I'm going to do a do show CDP neighbor, and we know that that switch is connected on the local interface, which is the interface on this switch, the student lab switch, is G00. So G00 is going to be the trunk switch, trunk port. So interface G00. Now, if you remember from before, I'm not going to go through the error again. I'm just going to set the encapsulation mode first, then make it a trunk port. So switch port, encapsulation. Oh, do I have to? Oh, let's see. Trunk, sorry, encapsulation. .1q, switch port mode trunk. Right. So now let's verify. Let's verify our VLAN. You could also do show VLAN brief, but I prefer I just do show VLAN because it's less typing. I mean, more will come out, but that's just what I do here on a small network. So we see 110 student labs created, and we have a port, switch port assigned to it. Perfect. Now let's look at the trunk link. Show in trunk, and we have explicit trunk with 802.1q. So that's good. So that's good to go. Now I'm going to go in. I'm going to create the VPC. I'm going to assign the VPC address. And because this is the next floor, I'm doing a .41. The net mask /24. Oh, I didn't do a gateway. 192.168.40. Again, I know what IP address I'm going to use for the SVI. That's why I'm doing it here this way. That way, once I set it, I can just test right away. And then let's do a show IP. And here we go. /24 network .10. We have the gateway set, and we're good. So now the fun part. Now we're going to go into the distribution switch. The distribution switch is going to you're going to put all the VLANs on the distribution switch. You're going to create the SVIs. You're going to assign them IP addresses. That way you can do InterVlan routing. Now this has a blank config, so I have another one set for routers, which is pretty close. Now this is a layer 3 switch, so there is IP route, so not everything is going to be the same, or not every command that you would use on a router works, but nothing that creates a problem. So for example, there's no polling interval on an L3 switch. There's no SNMP timeout, but that's fine. And for the most part, it does what I need it to do. So this is going to be secondary. I'm just going to make it switch. Now, what I did forget to do is the student lab, save the configuration. Now we had validated everything, that it was configured properly. Now we can go ahead and save the configuration. So we shut this off and turn it back on, our configuration is saved and good to go. Now with the distribution switch up, I'm going to start with layer 2 first, which means I'm going to create all the VLANs that this is responsible for handling communication between. Layer 2 first. So we're going to go into the configure, we're going to do VLAN 100, and then we're going to do VLAN 110. I can name them here, and I should for the sake of keeping everything standard. So I'm going to go to VLAN 100. I'm going to do name. I think it was IT department, but let me double check. I go to IP department and I do a show VLAN. No, sorry. Ooh, did I mess this one up? I did. Okay. Easy fix. Let me do the same thing here. Okay. So, because I'm not using VTP, VLAN Transport Protocol, and there's separate VLAN IDs, I don't have a problem, or there's no name conflict right now. Later on there could be, so I'm going to go ahead and fix that. So I'm going to go into int VLAN, no, sorry, not int. I'm just going to do VLAN 100 if I'm in configuration. And I'm going to name IT department. Let it do its thing. Let's see if updated, and it did. So now I'm going to save that. No harm, no foul. Done. Student lab is good. So now I know what I named it. So IT department. Now I'm going to go VLAN 110. Back on the distribution switch. I switched over. And this name is going to be student-lab. Is it? Student-lab. Okay. So student-lab. Layer 2 done. Now we're going to create the sub-virtual interface, or the SVIs. And because they're interfaces, we're going to do int VLAN 100. The interface you can assign an IP address. Oh, wait, hold on. That gets annoying. The interface you can assign an IP address, which is going to be, what did I use? .31.1. 255.255.255.0. Remember, on the access device, the gateway is the IP of this SVI. This SVI acts as the gateway for that subnet. So now I'm going to do the same thing for VLAN 110. IP address 192.168.41.1. It's a /24. I'm going to no shut it. I should have done the same thing with the other VLAN interface, VLAN 100. I'm going to no shut that as well. So now, let's validate our VLANs. So we have two VLANs here, 100, 110. Okay, perfect. IT department, student lab, good to go. I want you to notice something here. I did not assign a port to the VLAN. The reason why is because we're using the SVI. So if I do a show interface brief, or so show IP interface brief, here are your two VLAN interfaces with IP addresses, and they are up. And now what you could also do if you wanted to is you can specifically look at the interface, so interface VLAN 100, and here's where you get in the information. We get the IP address, the subnet mask is using. You'll see its bandwidth. You'll also see statistics, 5-minute input and output statistics if you wanted to do any kind of troubleshooting that way. So, looks like we're good. Let's test. So from the VPC, I should be able to ping the gateway. I might take a second for ARP to kick in, and it does, but here we go. Let's see if it works this way. Yeah, okay. So, it took a second. The reason why you got that timeout is because it took a second for these ARP packets to go back and forth. But we can ping the gateway. Let's see if we can ping the gateway for the other VLAN. And there we go. Okay, so we know we can ping the distribution switch or the gateways or the SVIs on the distribution switch. Can we actually traverse the switch and hit the other device? Well, let's find out. Ping 192.168.41.10. Probably takes a second for ARP to kick in, and there we go. So we have full connectivity between both floors on 2 separate VLANs. And the reason why you can do this is if you take a look at the distribution switch and you look at the routing table, there it has routes for each connected network. So each connected VLAN it has routes for. So when the packet goes from, let's say, here, goes up into the distribution switch, it goes, oh, I have a route for the other VLAN, so you go here. So that's how you configure VLANs and SVIs and how they work together. That's also how you use a, this isn't just, now this is a 3-tier architecture like I mentioned on a previous video, but this is the same thing as a router on a stick, just in a little bit more of a complex environment. The next thing we're going to work on is we're going to actually work on the core network side to get routing between networks. So that means being able to go from floor 2 of the secondary campus over to building A in the main campus. It also means being able to get out to the internet that we have here, and we'll work on things like setting up OSPF areas, OSPF routes, RIP v2. We're going to set point-to-point links. We're going to do all that stuff. We're going to work on the layer 3 stuff on a later video.